Welcome to my YouTube channel. Please don't forget to subscribe, like, and share.
Welcome to our Architecture Review Series Practice Quiz, and we had now part 3 of our Structural Conceptualization Quiz. So instructions before proceeding with the quiz, it is best to get a piece of paper muna, cut lengthwise, and then write down numbers 1 to 30 so that when you are ready, you can now start with the quiz, and for every question, write down the corresponding letter of your best choice or answer from the multiple choice. And you will be given 10 seconds to finalize your answer. At the end of the quiz, count the total number of your correct answers and check your score rating. So if you are now ready, good luck. Number 1. Horizontal spacing of rebars for firewall. A. Every 2 layers. B. Every 3 layers. C. Every 4 layers. And D. Every 5 layers. And our correct answer is every 3 layers, letter B. So this is the schedule for the rebars. 10 mm at every 3 layers. This is for all walls regardless whether it's firewall or CHB walls. And for vertical spacing is at 600 mm on center. Number 2 refers to long light gauge materials of various shapes and a non-structural metal attachment that is used to hold a finished material, and a method of supporting one layer of material over another, or holding insulation or other construction items between materials. A. Drywall. B. Steel frame. C. Steel deck. And D. Metal furring. And our correct answer is letter D, metal furring. So a metal furring refers to long, light gauge materials of various shapes and are non-structural metal attachments used to hold finished materials, support one layer over another, or hold insulation and other construction items in place. Number 3. What is the minimum compressive strength for a Class A concrete mixture? A. 2000 psi. B. 2,500 psi, C. 3,000 psi, and D. 3,500 psi. And our correct answer is letter C, 3,000 psi. So this is in accordance with the typical concrete compressive stress in the Philippines as per NSCP, which is in line with the requirements of ACI 318 standard, showing here that for Class A concrete, the minimum strength is 3,000 psi, equivalent to 20.7 MPa, and this is used for slabs, beams, columns, and foundations for residential or light commercial buildings. Number 4. What is the area in square meters of the trapezoid concrete pavement if its dimensions are 15 meters and 10 meters length, parallel to each other? So yung 15 and 10 are parallel to each other. And the depth of the trapezoid is 8 meters, which is perpendicular to its length, perpendicular doon sa 15 and 10 meters. And this pavement has a thickness of 4 inches. So you may get your calculator and start your computations. So the choices are A. 120 square meters, B. 80 square meters, C. 140 square meters, and D. 100 square meters. And our correct answer is letter D, 100 square meters. So how do you compute for the area of a trapezoid? So we make use of this formula. So these are the two parallel lengths, A and B, 15 and 10 meters. So we have to add those two and divide it by 2 and multiply it by the perpendicular, and this is our perpendicular, 8 meters. Okay, so multiply it by 8 meters, so it means 15 plus 10 divided by 2, that is 15 divided by 2, 25 divided by 2 is 12.5 times the height or the perpendicular of 8 meters will give you 100 square meters. Okay, so ganun lang, you have to check this perpendicular dimension, not this dimension but the perpendicular to the two lengths. Number 5, what is the volume in cubic meters? So this is the same as the previous question. So again, get ready with your calculator. This is the trapezoid concrete pavement with dimensions 15 meters and 10 meters length parallel to each other, and the depth is 8 meters perpendicular to its length with a thickness of 4 inches. So we are now going to compute for the volume. So we have now to consider the thickness of 4 inches. We only have to multiply, of course, the area of the trapezoid times the thickness of 4 inches. Okay, the choices are 8 cubic meters, B 10, C 12, and D 14. Okay, and so our volume is, of course, our area times the thickness of 0.1 will give you 10 cubic meters. So ang ating area kanina is 100 square meters, and then we only have to multiply it by the thickness of 4 inches or 0.1 meters will give you 0.1 meter will give you 10 cubic meters. And number 6, this is the same again as the previous question. You have a trapezoid concrete pavement, and what is being asked is the bags of 43 kilogram cement required for this trapezoid concrete pavement. Dimensions are the same, 15 meters and 10 meters length parallel to each other, and depth is 8 meters perpendicular to its length with a thickness of 4 inches. And using Class C concrete mix ratio. So which means that we have already computed the area and the volume kanina, and so we are now going to determine how many cement do we need for a Class C concrete mix for that concrete volume. So the choices are 45 bags, B 56 bags, C 67 bags, and D 78 bags. And our correct answer is letter B, 56 bags. Although there is no 43 kilogram cement bags, available is only 40 kilos bag and 50 kilos, in some cases, 50 kilos cement bags. So those are the only two available packaging for cement. So ito I think this is just a hypothetical question just to determine whether you know how to compute. Okay? So we have already computed the area of the trapezoid and the volume using the thickness of 4 inches. We have arrived at the volume of concrete at 10 cubic meters. So we first check how many bags of cement do we need using a 40 kilos packaging. So using this tabulation for a Class C concrete mixture, you need 6 bags of 40 kilogram packaging per cubic meter of concrete volume. So which means that we only have to multiply this volume of concrete, 10 cubic meters, by the number of cement bags na 40 kilogram packaging, and that will give you 60 bags, 40 kilos. So we multiply the weight. It will give you now 2,400 kilograms cement requirement. So to determine how many bags of 43 kilos packaging, we only have to divide this 2,400 kilograms by 43 kilograms to get the number of bags. And that will give you 55.8 bags, or round off to 56 bags. Okay. So this is the same as the previous situation, but this one, what is being asked is how many cubic meters of sand are required for this trapezoid concrete pavement. Dimensions 15 meters and 10 meters length parallel to each other, and depth is 8 meters perpendicular to its length with a thickness of 4 inches, and using Class C concrete mix ratio. So again, we have to consider the volume of concrete, no? And the requirements for Class C concrete mix. So our choices is 4 cubic meters of sand, B 5 cubic meters, C 6 cubic meters, and D 7 cubic meters of sand. And our correct answer is letter B, 5 cubic meters of sand. So this is our area and volume. Our volume of concrete is 10 cubic meters, and for all concrete mixtures, for every cubic meter of concrete volume, you need 0.5 cubic meters of sand. So which means you only have to multiply this volume of concrete by 0.5 to get you the volume of sand. So 10 cubic meters times 0.5 will give you now the requirement for sand at 5 cubic meters. Number 8. How again, this is the same question situation as the previous one, and what is being asked is the how many cubic meters of gravel will be required now for this trapezoid concrete pavement. Again, the dimensions are 15 meters and 10 meters length parallel to each other, and depth is 8 meters perpendicular to its length with a thickness of 4 inches. Again, using Class C concrete mix ratio. Our choices will be A 7 cubic meters of gravel, B 9, C 11, and D 13 cubic meters. And our correct answer here among the choices is letter C, 11 cubic meters. So previously we have computed already the volume of concrete at 10 cubic meters, and according to this table, for every cubic meters of concrete, you need also 1 cubic meter of gravel. So that is a 1:1 ratio. No? So which means that if our concrete volume is 10 cubic meters, it follows that our volume for gravel is also 10 cubic meters. Okay, but there is no 10 cubic meters here. The only one available is 11. Now we cannot choose 9 because that is smaller. So 9, what is indicated in figure below? A, S purlin, B, inverted purlin, C, channel, D, Z purlin. And our answer is letter D, is Z purlin. So a Z purlin is a cold formed light gauge steel section shaped like the letter Z, commonly used in roofing and wall construction. It acts as a secondary framing member that spans between main steel frames. It provides support for roof sheeting or wall cladding. Its Z-shape allows easy lapping and continuity over support. So pag nagdudugtong, mas madali, no, ang Z-frame. It making it stronger and more efficient than C purlins in some applications. It is commonly used in metal buildings, warehouses, factories, and sheds. Number 10. What is indicated in the figure below? A. Z channel, B. C channel, C. Z channel, and D. Inverted Z channel. And our correct answer is letter B, C channel. So a C channel is a steel section shaped like the letter C, commonly used in structural framing. It acts as a primary or secondary structural member, often used for beams, columns, or purlins. It provides strength and stiffness in one direction due to its flanges and web. It can be made of hot-rolled or cold-formed steel. So ito yung ating ginagamit na C purlin. How do we compare a Z purlin versus a Z purlin? So both are used in roof and wall framing, but Z purlins are specifically designed for overlapping at the supports dito, for continuous spans, while C channels are more straightforward structural members and are easier to attach directly to frames. Number 11. What is indicated in the figure below? A. Camber, B. Post-tensioning anchor, C. Beam anchor, and D. Anchor system. And our correct answer is letter B. Post-tensioning anchor. So a post-tensioning anchor is a specialized anchorage device used in post-tension concrete structures to hold the pre-stressing tendons or steel strands or bars in place after tensioning. It transfers the pre-stressing force from the tendon into the concrete member, ensuring structural strength and stability. Its key features are high load capacity, durability, and the ability to provide long-term stress transfer without slippage. Number 12. What is indicated in the figure below? A. T flange, B. Wide flange, C. Wide beam, and D. C beam. And our correct answer is letter B, wide flange. So a wide flange, or WF, is a structural steel beam or column shaped like an I or H with wide flanges and a thinner web. It is commonly used in buildings, bridges, and industrial structures with high strength-to-weight ratio. Number 13. What is indicated in the figure below? A. Waffle slab, B. Slab waffle, C. Flat slab, and D. Two-way precast slab. And our correct answer is letter C, flat slab. So a flat slab is a type of reinforced concrete slab supported directly by columns without the use of beams. It is widely used in buildings, parking structures, and offices for its flexibility in layout and reduced construction height. Its key benefits are simplified formwork, faster construction, and improved aesthetics with flat ceilings. 14. What is indicated in the figure below? A. Truss bracing, B. Howe truss, C. King post truss, and D. Warren truss. And our correct answer is letter B, Howe truss. So this is a Howe truss, and this is a double Howe truss. And a king post truss will look like this. You have the king post and two webs here. And a Warren truss is this one, usually for bridges. Truss bracing is not a type of roof truss. And 15, what is indicated in the figure below? A. Truss bracing, B. Petit truss, C. King post truss, and D. Warren truss. So our correct answer is letter B, petite truss. So the petite truss, or sometimes called the petite type truss or Pennsylvania petite truss, is a variation of the Pratt truss, used mainly in long-span bridges. It combines the diagonal tension members of a Pratt truss with additional sub-diagonals in longer panels to reduce member length and control deflection. Number 16. Where would you normally use the figure below? A. Beam, B. Bridges, C. Column, and D. Slab. And our correct answer is letter B, bridges. So post-tensioning anchors are most commonly used in bridges and long-span structures because they hold the pre-stressing tendons in place after tensioning, transferring the force into the concrete. They can also be used in slabs and beams, but the most typical and critical application is in bridges. 17. What is the minimum diameter for rebars of stirrups? A. 10 mm, B. 12 mm, C. 16 mm, and D. 20 mm. And our correct answer is letter A, 10 mm. So stirrups are for beams and ties is for columns. So based on the National Structural Code of the Philippines, NSCP, and ACI 318, stirrups for beam shear reinforcement is minimum 10 mm diameter bars, and for column ties for lateral reinforcement, minimum of 10 mm for columns with main bars up to 32 mm diameter, and minimum of 12 mm diameter for columns with main bars larger than 32 mm. 18. Based on ASTM, number 3 bar is blank. 8 mm diameter, B. 10 mm diameter, C. 12 mm diameter, and D. 16 mm diameter. And our correct answer is letter B, 10 mm diameter. So to compute for the diameter, the dimension of a imperial bar size number 3, you only have to divide that bar size number by 8 and multiply it by 25.4. So you will get 9.525 mm diameter, but there is no commercially available 9.5. Our commercially available is 10 mm diameter. So that is number 3. So number 4 is 13 mm or 12 mm. Number 5 is 16 mm. Number 6 is 19 or 20 mm. The commercially available bar diameters. Number 19. Column that raises or supports a mass of a structure above the ground. A. Pier, B. Stilts, C. Posts, and D. Piles. And our correct answer is letter B, stilts. So stilts are columns or posts that elevate a structure above the ground or water, allowing ventilation, flood protection, or stability on an even terrain. So according to D.K. Ching, stilt is one of several piles or posts for supporting a structure above the surface of land or water. While on the other hand, a pier is a massive upright support, usually masonry, stone, or concrete, for heavy structures like bridges, arches, or arcades. So in short, piers are massive supports for arches or bridges, while stilts are slender supports lifting house structures above ground or water. So this is from D.K. Ching again. Accordingly, a pier is a vertical supporting structure as a section of wall, this one, between two openings, this is door and window opening, or one supporting the end of an arch or lintel. 20. Long column is designed for A. Buckling, B. Crushing, C. Elongation, and D. Hardness. And our correct answer is letter A, buckling. So a long column is slender, so under compressive load, it fails mainly by buckling, that is lateral bending or instability, rather than by crushing. So we have what you call flexural buckling and also torsional buckling and flexural torsional buckling. Number 21, advantage of steel over concrete. A. Rigidity. B. Elasticity. C. Thermal insulation. And D. Hardness. And our correct answer is letter B, elasticity. So steel has greater elasticity and tensile strength compared to concrete. This means it can deform under load and return to its original shape. And it resists tension and bending much better than concrete, which is strong only in compression. So this is the Young's modulus showing the module of elasticity. 22. What is the purpose of stirrups in a beam aside from carrying and resisting load? A. To resist shrinkage. B. To hold longitudinal bars in place. And C. To resist flexure. And D. None of the above. And our correct answer is letter B, to hold longitudinal bars in place. So stirrups in a beam, aside from resisting shear loads, serve the important purpose of holding the longitudinal bars in place, keeping them properly aligned and confined during concreting to ensure structural stability. So smaller diameter steel bars that are made into closed hoops and are closed loops and are placed at regular intervals along the full length of the beam, while the main rebars or the longitudinal bars are the larger diameter steel bars that go through the full length of the beam. 23. What is a method of pre-stressing in which tendons are tensioned before concrete is placed? A. Pre-tensioning. B. Post-tensioning. C. Pre-casting. And D. Pre-fabrication. And our correct answer is letter A, pre-tensioning. So in pre-tensioning, the steel tendons are stretched first. This one. Then concrete is cast around them. And once the concrete gains strength, the tension is released, transferring compressive stress to the concrete. That is the difference between a post-tensioned concrete. And 24. What is a short steel bar extending from one concrete element to another, as for instance a concrete foundation to a concrete column, which may or may not transfer direct stress? A. Corbel. B. Temperature bars. C. Stirrups. And D. Dowel. And our correct answer is letter D, dowel. So a short steel bar that extends from one concrete element to another, such as from a concrete foundation to a concrete column, and may or may not transfer direct stress, is called a dowel. A corbel is a short cantilever projection from a wall or column designed to support a load above, such as beams, arches, or slabs. Temperature bars are the reinforcing bars placed in slabs or walls to minimize cracks caused by shrinkage and temperature changes. And stirrups are the closed-loop reinforcement in beams, primarily to resist shear forces and hold longitudinal bars in place. 25. What is a web found in a structural member? A. Rafter, B. Roof truss, C. Purlin, and D. Batten. And our correct answer is letter B, roof truss. So in structural terms, the web is the vertical or diagonal part of a structural member like an I-beam or truss that connects the flanges and resists shear. The correct answer is roof truss because the web members are the diagonal or vertical components inside the truss that transfer shear forces between the top and bottom chords. A rafter is a sloping beam supporting a roof, a single solid member, and does not have a web. Purlin is a horizontal member laid across rafters or trusses to support roofing sheets and do not have a web. They are single solid members. And batten is a thin strip of wood or metal used to secure roof tiles, shingles, or other materials to the rafters or purlins. Like rafters and purlins, they are single pieces and do not have a web. 26. What foundation presents the most disturbance and potential damage to neighboring lots? A. Board piles, B. Isolated footing, C. Sheet pile, and D. Footing with tie beams. And our correct answer is letter C, sheet pile. So sheet piles are driven into the ground by vibration or hammering, which can cause ground movement, noise, and vibration, potentially disturbing adjacent structures and soil stability. Board piles has less vibration since drilling or boring is used instead of driving, so less disturbance. Isolated footing is just a shallow foundation, so it has minimal disturbance, limited only to its excavation. And footing with tie beams also is shallow, and disturbance is only localized excavation. 27. Ready mixed concrete should be tested at blank. A. Site, B. Office, C. Plant, and D. ASTM. And our correct answer is letter A, site. So the quality of ready mixed concrete must be checked at the point of delivery or site because factors like transport time, handling, and site conditions affect its performance. Typical site tests will be the slump test for workability, temperature test, and preparation of cylinder or cube samples for strength testing. Testing at the plant ensures mixed proportions, but final acceptance is based on site tests. Testing ready mixed concrete on site is essential for ensuring that it meets the required specifications for a project. 28. Your client asks you to erect a commercial building on what used to be a rice field. On what soil must the foundation rest? A. Soft, B. Medium, C. Hard, and D. Very hard. And our correct answer is letter D, very hard. So for maximum safety and long-term stability, especially for a commercial building, the best answer is very hard. So very hard soil or bedrock has the highest bearing capacity and experiences negligible settlement, making it the most reliable choice for large, heavy commercial buildings, especially on problematic sites like former rice fields. So you must reach even pile foundation should reach up to the hard soil or rock. Hard soil is strong and usable, but under extreme loads, it may still undergo minor settlement, which over time can affect alignment and cause cracks. So 29. What happens to newly placed concrete in the beam, slab, or column if it is not properly vibrated? A. Honeycomb, B. Slow to harden, C. The concrete will strengthen. And D. Ugly surface. And our correct answer is letter A. Honeycomb. So the honeycomb are the voids and the gaps caused by entrapped air and poor consolidation. It weakens the concrete, reduces durability, and exposes reinforcement to corrosion. And 30. Water used for concrete mix. A. Clean water. B. Distilled water. C. Potable water. And D. Hot water. And our correct answer is letter C. Potable water. So potable water is safe for drinking, generally free of harmful salts, oils, and acids, and organic matter that could affect cement hydration and concrete strength. Clean water sounds correct, but the standard requirement in practice is potable water, since not all clean-looking water is chemically safe. And that's it for our quiz. Congratulations for completing the quiz. Now, count your total correct answers and determine your score category. If your rating is 15 or less, it is time for a more strategic review.
Thanks for watching. Don't forget to subscribe, like, and share.
Enroll at Atlas CDC Review for a comprehensive prep for the Architecture Board exams. Message us now.